Inside all those massive industrial machines, we're talking everything from factory gears to the transmission in your car, there's this constant invisible battle going on. It's a fight against friction. And today, we're going to dive into a really cool discovery that's completely changing how we fight it, making our machines not just greener, but a whole lot stronger. So, get ready for this number. According to the U.S. Department of Energy, a mind-blowing 62.4% of the energy a typical machine uses is lost to friction. It just turns into waste heat. Think about that for a second. More than half of the power we put in just vanishes.
And that energy loss? It's not just a small inefficiency. It's a huge global problem. And for decades, scientists and engineers have been on this epic mission to try and get that lost power back.
You see, friction is a real double whammy. First, it's an energy thief, just stealing power and forcing us to burn way more fuel than we should. And second, it causes all that physical wear and tear, literally grinding down machine parts until they fail. The one thing standing in its way? Lubricants. For the longest time, we've relied on traditional oils made from petroleum. And look, they work pretty well, but they come from fossil fuels. So now there's this big global push toward greener, bio-based lubricants, stuff made from renewable things like vegetable oils. But here's the catch. These new green oils have a totally different chemical vibe, and our old tricks don't always work with them.
And that, right there, is where our story really kicks off. It's about the search for a new kind of additive. That special sauce you mix into the oil to make it better? One that can work its magic in these new eco-friendly lubricants.
But think about it. How do you even figure out if a new lubricant is tough enough? You can't just pour it into a billion-dollar machine and cross your fingers, right? No way. You have to push it to its absolute limit in a lab. And the way they do it is, well, it's pretty intense.
They've got this gnarly procedure called the 4-ball extreme pressure test. Basically, you take 3 steel balls, lock them in a cup, and douse them in the lubricant you're testing. Then you press a 4th ball on top and spin it like crazy while piling on more and more weight. You're looking for the exact breaking point. That moment, the pressure gets so insane that the lubricant just gives up and the steel balls literally weld themselves together.
So, armed with this brutal test, researchers went looking for a new additive. They had a really promising candidate lined up, but what they found was something nobody saw coming.
All right, so meet our new contender. It's a molybdenum-based compound they nicknamed MoMEA. Now you gotta understand, molybdenum is kind of famous in the chemistry world for creating super slippery, low-friction surfaces. This stuff was supposed to be the hero ingredient, for sure.
But this is where the story takes a crazy turn. In that 4-ball test, the plain base oil all by itself could handle 200 kilograms of pressure before failing. But when they added the supposedly amazing MoMEA additive, the performance actually got worse. It failed at only 160 kilograms. The hero was actually making things weaker. What on earth was going on?
Whenever you get a result in science that makes zero sense, it usually means you're missing a key piece of the puzzle. The researchers started to think, maybe MoMEA wasn't supposed to be a solo act. Maybe it was meant to be a team player. And this, folks, is where the story gets really, really good.
The missing piece of the puzzle? It's a powerful idea called synergy. It's the concept that sometimes, when you combine two things, the result you get is way more powerful than what you'd expect from just adding them up. It's like the scientific version of 1 + 1 = 3. So the researchers took their failed MoMEA additive and started pairing it with other existing additives. The results were just, wow. The blue bars here show what the other additives could do on their own. But the red bars? That's what happens when you add MoMEA into the mix. The performance doesn't just get a little better, it absolutely skyrockets. That is synergy in action.
So what was the magic formula? What was this winning combination that unlocked such an incredible boost in performance? Well, the most dramatic results by far happened when MoMEA was teamed up with another additive, a sulfur compound called DMTD. This combo was so good that the researchers pointed out it could finally open the door to making high-performance lubricants that are completely phosphorus-free, which is a huge deal for environmental regulations. And the wins just kept on coming. This dream team didn't just handle insane pressure, it also offered incredible protection for the machine parts. In their tests, instead of letting the metal corrode, it actually built up a protective layer on it. Plus, it was the best at resisting oxidation, which just means the oil won't break down when things get super hot. It wasn't just stronger, it made everything last longer.
So what's the secret? How does it work?
Well, under all the intense heat and pressure inside a running machine, the MoMEA and the DMTD have a chemical reaction. Together, they form this microscopic, ultra-tough shield of molybdenum disulfide, or MOS2, right on the metal surface. And MOS2 is legendary for being an incredible solid lubricant. So this formula is essentially building its own armor plating right where you need it most.
Now, this is so much more than just a neat little lab experiment. This discovery really points to a massive shift in how we think about keeping our industrial world running smoothly.
So, why does this all matter? Let's break it down. First, it's a giant leap forward for making lubricants that are both super powerful and good for the planet. Second, it gives us a clear roadmap to finally phase out harmful phosphorus additives. And maybe most important, it's just an amazing reminder that sometimes the biggest breakthroughs don't come from one single miracle cure, but from discovering the hidden power of teamwork.
And that leaves you with a pretty cool final thought. I mean, this was a story about making oil better, but the principle behind it is universal. If finding the right chemical team-up can solve a decades-old engineering problem, what other massive challenges in medicine, in new materials, in clean energy are just sitting there, waiting for us to discover their own hidden synergy?